In systems engineering, dependability is a measure of a system's availability, reliability, and its maintainability. This may also encompass mechanisms designed to increase and maintain the dependability of a system. The International Electrotechnical Commission, via its Technical Committee TC56, develops and maintains international standards that provide systematic methods and tools for dependability assessment and management of equipment, services, and systems throughout their life cycles. Dependability can be broken down into three elements: attributes, a way to assess the dependability of a system; threats, an understanding of the things that can affect the dependability of a system; means, ways to increase a system's dependability. History. Some sources hold that word was coined in the 19-teens in Dodge Brothers automobile print advertising, but the word predates that period, with the Oxford English Dictionary finding its first use in 1901. As interest in fault tolerance and system reliability increased in the 1960s and 1970s, dependability came to be a measure of X, as measures of reliability came to encompass additional measures like safety and integrity. In the early 1980s, Jean-Claude Laprie thus chose dependability as the term to encompass studies of fault tolerance and system reliability without the extension of meaning inherent in reliability. The field of dependability has evolved from these beginnings to be an internationally active field of research fostered by a number of prominent international conferences, notably the International Conference on Dependable Systems and Networks, the International Symposium on Reliable Distributed Systems, and the International Symposium on Software Reliability Engineering. Dependability for a system incorporates the following attributes or unfunctional requirements: availability, readiness for correct service, reliability, continuity of correct service, maintainability, to undergo modifications and repairs, and combines them with the concepts of threats and failures to create dependability. Since the 1980s, safety and security have been added to measures of dependability. Elements of dependability. Attributes. Attributes are qualities of a system. These can be assessed to determine its overall dependability using qualitative or quantitative measures. Avicenna et al. Define the following dependability attributes: availability, readiness for correct service, reliability, continuity of correct service, safety, absence of catastrophic consequences on the user and the environment, integrity, absence of improper system alteration, maintainability, ability for a process to undergo modifications and repairs. As these definitions suggested, only availability and reliability are quantifiable by direct measurements, whilst others are more subjective. For instance, safety cannot be measured directly via metrics but is a subjective assessment that requires judgmental information to be applied to give a level of confidence, whilst reliability can be measured as failures over time. Confidentiality, i.e., the absence of unauthorized disclosure of information, is also used when addressing security. Security is a composite of confidentiality, integrity, and availability. Security is sometimes classed as an attribute, but the current view is to aggregate it together with dependability and treat dependability as a composite term called dependability and security. Practically, applying security measures to the appliances of a system generally improves the dependability by limiting the number of externally originated errors. Threats of things that can affect a system and cause a drop in dependability. There are three main terms that must be clearly understood. Fault. A fault is a defect in a system. The presence of a fault in a system may or may not lead to a failure. For instance, although a system may contain a fault, its input and state conditions may never cause this fault to be executed so that an error occurs, and thus that particular fault never exhibits as a failure. Error. An error is a discrepancy between the intended behavior of a system and its actual behavior inside the system boundary. Errors occur at runtime when some part of the system enters an unexpected state due to the activation of a fault. Since errors are generated from invalid states, they are hard to observe without special mechanisms, such as debuggers or debug output to logs. Failure. A failure is an instance in time when a system displays behavior that is contrary to its specification. An error may not necessarily cause a failure. For instance, an exception may be thrown by a system, but this may be caught and handled using fault tolerance techniques, so the overall operation of the system will conform to the specification. It is important to note that failures are recorded at the system boundary. They are basically errors that have propagated to the system boundary and have become observable. Faults, errors and failures operate according to a mechanism. This mechanism is sometimes known as a fault-error-failure chain. Once a fault is activated, an error is created. An error may act in the same way as a fault in that it can create further error conditions. Therefore, an error may propagate multiple times within a system boundary without causing an observable failure. If an error propagates outside the system boundary, a failure is said to occur. A failure is basically the point at which it can be said that a service is failing to meet its specification. Since the output data from one service may be fed into another, a failure in one service may propagate into another service as a fault, so a chain can be formed of the form fault leading to error, leading to failure, leading to error, etc. Means since the mechanism of a fault-error chain is understood, it is possible to construct means to break these chains and thereby increase the dependability of a system. 4 means have been identified so far: prevention, removal, forecasting, tolerance. Fault prevention deals with preventing faults being incorporated into a system. This can be accomplished by use of development methodologies and good implementation techniques. Fault removal can be subdivided into 2 subcategories: removal during development and removal during use. Removal during development requires verification so that faults can be detected and removed before a system is put into production. Once systems have been put into production, a system is needed to record failures and remove them via a maintenance cycle. Fault forecasting predicts likely faults so that they can be removed or their effects can be circumvented. Fault tolerance deals with putting mechanisms in place that will allow a system to still deliver the required service in the presence of faults, although that service may be at a degraded level. Dependability means are intended to reduce the number of failures presented to the user of a system. Failures are traditionally recorded over time, and it is useful to understand how their frequency is measured so that the effectiveness of means can be assessed. Dependability of information systems and survivability. Recent works, such upon dependability, take benefit of structured information systems, e.g., with SOA, to introduce a more efficient ability, the survivability, thus taking into account the degraded services that an information system sustains or resumes after a non-maskable failure. The flexibility of current frameworks encourage system architects to enable reconfiguration mechanisms that refocus the available, safe resources to support the most critical services rather than over-provisioning to build failure-proof system. With the generalization of networked information systems, accessibility was introduced to give greater importance to users' experience, to take into account the level of performance. The measurement of performability is defined as quantifying how well the object system performs in the presence of faults over a specified period of time.